If you needed to know exactly what the law says today, like right now, how would you find out?
I mean, I'd probably just Google it.
Right. Really think about your workflow for a second. You would open a browser, look up the relevant statute on, an official government database, and you would completely trust the text on that screen.
Because it's the government, right? You assume they have it handled.
Exactly. It's the government after all. But what if I told you that you are trusting a system that is fundamentally broken?
Which is a terrifying thought.
It really is. Today, we're doing a deep dive into a stack of internal documents and technical papers from a project called LawVM. And what these sources reveal is that the text you're reading online is likely just a human-curated summary of decades of scattered patches.
Yeah.
And occasionally that text is just completely factually wrong.
It's wild. It forces a total reevaluation of how we view legal infrastructure. We operate under this assumption that the law is a monolithic, perfectly synchronized database.
Right, like one big master file.
Exactly. We assume the screen displays exactly what the legislature passed. But as the LawVM research demonstrates, we actually suffer from a profound inability to mathematically prove that the text we read matches the rules that were actually enacted.
Which is just wild to think about. I mean, we're going to unpack why, for at least the last 30 years, nobody has been able to say with absolute certainty what the law even says.
Nobody.
Yeah. We'll look at the hidden structural mechanics of how laws are drafted, why the entire tech industry missed a very obvious solution by, getting distracted by AI.
As they do.
As they do. And how LawVM is finally fixing this by treating human-written legal text as an executable computer program.
Okay, let's unpack this, because to really grasp the scale of the problem, we need to dismantle the illusion of what you might call current law.
Okay, current law. Break that down for me.
So the core issue is that law is an incrementally maintained system. Parliaments, they rarely sit down and rewrite an entire legal code from scratch.
That would take forever.
Right. Instead, when a policy changes, they pass an amendment. Think of these amendments as software patches. They target and modify specific provisions from a base statute that, well, it might have been written in the 1970s.
So they aren't publishing a fresh document every time. They're just issuing an instruction like, go to Section 4, subsection 2, and change the word 30 to 40.
That is the exact mechanism.
Yeah.
And over decades, the law becomes a massive, tangled palimpsest.
A what?
A palimpsest. It was a historical manuscript where older writing was scraped off so the parchment could be reused.
Oh, right. But traces of the old text remain beneath the new stuff.
Exactly. Modern law is authored by distributed agents over time, so you have different parliaments, different decades, shifting political mandates, and they are all patching the exact same historical document.
And that sounds like a mess.
It is. Because of this scattered patching, the LawVM sources point out that there are actually 4 truth surfaces in legal information systems.
4. That immediately sounds like a vulnerability. I mean, if you have 4 different versions of the truth, somebody's going to read the wrong one.
And they frequently do. The foundational surface is the enacted event truth.
Okay.
This is what the Parliament actually voted on and decided. It consists of the original base statute plus every single individual amending act exactly as it was published in the official Gazette.
So the raw updates.
Right. In Finland, which LawVM uses as its primary proving ground, this Gazette is called the Säädöskokoelma. Legally speaking, this is the primary surface, but it is practically unreadable for a normal citizen.
Well, yeah, because it's just a chronological dump of diffs.
Yeah.
If you want to know your tax liability for this year, you can't be expected to read the 1995 base tax law and then, manually apply 400 separate patches in your head to calculate the current rate.
Nobody could do that, which is why almost everyone, including judges and lawyers, relies on the second surface, which is the revised or editorial truth.
Okay, the editorial truth.
Yeah. This is a consolidated text maintained by a team of human editors. In Finland, this is the official Finlex database. These editors, they read the enacted patches as they are published and manually update a master document so you can read the current state of the law in one cohesive place.
Wait, I want to pause on that because it reveals a massive gap.
Go for it.
If I'm relying on an editorial consolidation, that's functionally the same as reading a fan-curated wiki page about a video game instead of reading the actual developer patch notes.
That's a great analogy.
Because, I mean, the wiki is highly convenient, but if a human editor makes a typo or forgets to update a section, the actual game doesn't change. The game still runs on the real code.
Exactly.
Well, with law, surely there's a safety net. I mean, if
Yeah.
the official government Finlex database says the law is X, isn't that legally binding even if the editor's made a mistake?
You would think so, right? That depends heavily on the jurisdiction. In Finland and in many other countries, actually, the answer is no.
Wait, no?
No. The official Finlex consolidation is purely informational. It carries zero legal authority.
That is a staggering liability for any business or citizen relying on that database.
It is a huge liability. The actual binding law is only the original statute plus those scattered amendment acts in the Gazette.
Wow.
If the Finlex editors miss an amendment or accidentally delete a paragraph while copy-pasting, you are still legally bound by the hidden, unapplied patch in the Gazette.
So you cannot stand in a courtroom and use the government's own database as a defense if that database is out of sync with the enacted patches.
You absolutely cannot.
That is insane. But if this is just a completely mechanical problem of applying text updates to a master document, I struggle to understand how this wasn't solved decades ago. We've had document automation for a long time.
We have.
Why hasn't someone just written a script to automatically apply the patches?
So the historical blind spot here is fascinating. People actually did start looking at this back in the 1990s. Yeah. A researcher named Arnold Moore used what are called ATN parsers, augmented transition networks, to try and automatically process Tasmanian legal amendments.
Okay, so they had the right idea.
They did, but the research largely stalled out after that. The tech world basically abandoned the purely mechanical parsing of text because they got distracted by the allure of trying to compute the meaning of the law.
Ah, the classic tech industry pivot.
Right.
Instead of building the boring, reliable plumbing, everyone wanted to build the shiny artificial intelligence. So instead of treating legal amendments as syntax, they started treating them like semantic puzzles they needed a machine to solve.
That's a great way to put it. For decades, the focus shifted to semantic AI, legal ontologies, and frameworks like Legal Rule ML. Technologists looked at human-written legal text, decided it was too messy and ambiguous to work with, and assumed the only path forward was to entirely rewrite the law into a formal programming language.
Just rewrite all the laws. Easy.
Yeah, simple, right. And more recently, they've been throwing large language models at the problem, hoping an AI will just naturally understand the intent of the text.
But if we apply that logic, they are putting the cart before the horse.
How so?
Well, trying to map semantic meaning using an LLM on a legal database is like trying to translate a novel into French before the author has even finished finalizing the English manuscript.
Oh, totally.
If the underlying text state is broken, like if the database is missing a paragraph because a human editor forgot to paste it, the AI is just going to confidently hallucinate legal advice based on corrupted data.
Yes.
You need a mathematically verifiable copy of the text before you can even begin to analyze its meaning.
That is the exact trap the industry fell into. They fundamentally misunderstood the nature of legislative text. They assumed it was just free-flowing, unstructured human prose.
Which it isn't?
No, not at all. The LawVM sources heavily emphasize that law is already highly structured. It has to be. Law requires stable, fine-grained addresses, like Chapter 2, Section 12, Subsection 3. It needs those so that other statutes, court decisions, and private contracts can reference it without the whole system breaking down.
It functions almost exactly like an API contract in software development.
Exactly.
You need a highly specific endpoint to call the function. Otherwise, the system throws an error.
Yes. And to maintain those addresses, the way amendments are drafted is incredibly strict. In Finland, there is a legislative drafting guide called the Lainkirjoittajan oppas.
Okay.
It heavily regulates the preamble of any amendment. It prescribes the exact order of operations, the specific verbs to use, like repeal, amend, or insert, and it mandates the exact hierarchical paths.
So if the text already follows a strict semi-formal instruction language, it doesn't need an AI to decipher its profound semantic meaning.
No.
It just needs a compiler. It needs a program that scans the text, identifies the verb replace, identifies the target section for, and extracts the payload text to paste in.
That realization is the core innovation of LawVM. Because technologists misunderstood that structured nature, they missed the opportunity to simply compile the law at the text layer.
They overthought it.
Way overthought it. They were trying to build semantic reasoning systems when what they actually needed was a deterministic text-state compiler. LawVM steps in to finally execute on that premise.
So let's get under the hood of how LawVM actually achieves this mechanically. If they aren't relying on LLMs or statistical guessing, how are they turning human finished text into an executable instruction stream?
The architecture is built around a deterministic replay compiler,
Deterministic meaning.
meaning that given the exact same inputs, it will always produce the identical output. There is no statistical weighting, no AI hallucinations. It takes the raw amendment text from the official Gazette and uses conventional grammar parsers.
Okay, by conventional parsers, we are talking about traditional computer science techniques.
Right.
Building an abstract syntax tree, or AST, based on strict grammatical rules.
Correct. The parser scans the preamble of the amendment. When it hits a structured phrase, it maps that phrase to a typed operation.
Got it.
It identifies the target address, selects the operation, whether that's replace, repeal, insert, or renumber, and extracts the new text payload.
And then what?
It then literally replays the history of the law, applying those patches sequentially over decades to construct the exact point-in-time state of the base statute.
Wow. If you are a software developer listening to this, you are probably picturing version control right now. It sounds identical to Git, where you have a base commit and then you just replay a massive log of diffs to arrive at the current build.
It's a very similar concept.
But I imagine legal time is vastly more complicated than software time. Code executes when you deploy it, but a law might be passed today and not take effect for years.
Time is perhaps the most complex variable the compiler has to handle. LawVM manages what the researchers call bitemporal consequences.
Bitemporal, so two timelines.
Exactly. In legal systems, time is not a single linear track. You have the transaction time, which is when the Parliament published the amendment, and the valid time, which is when the rule actually takes effect in the real world.
So Parliament publishes a patch in December 2024. The law is technically on the books, but the text explicitly states the new tax rate doesn't apply until January 2026.
Right. And during that interim period, the amendment is legally valid, but the active text of the statute hasn't changed yet.
Oh, that's tricky.
Yeah. LawVM has to hold that instruction in memory, mapped to a future temporal coordinate. And it goes in the other direction, too. Sometimes laws are retroactive.
Oh, no.
Yeah, an amendment passed today might dictate that a rule applies retroactively to everything that occurred since last November. The compiler has to mathematically map all these overlapping temporal vectors without corrupting the historical state of the text.
That alone is a massive tracking challenge. But the sources mention something that seems to break even those rules. They refer to core agenda as essentially the final boss of compiling law. How does a core agendum disrupt that timeline?
So core agenda are official correction notices. Imagine Parliament passes an amendment, but a month later they realize there was a massive typographical error in the amendment itself.
Whoops.
Yeah, big whoops. They publish a core agendum to fix the typo. Most traditional legal databases just treat these as flat editorial footnotes. A human editor quietly goes into the consolidated text, fixes the typo, and moves on.
But if you are building a deterministic compiler, you can't just quietly edit the past. You need an unbroken mathematical chain.
Exactly. So LawVM has to treat core agenda as higher order operations. A normal amendment is an operation on the base statute. A core agendum is an operation that modifies a prior amendment operation.
Wait, it intercepts the instruction stream?
Yes, it intercepts it.
So going back to the Git analogy, this isn't just a new commit, this is an interactive rebase.
That's a great way to look at it.
It's an instruction that says, go back in time, find the commit from last month, alter the payload of that specific commit, and then allow it to execute normally when its effective date arrives.
That is a highly accurate way to visualize it. It rewrites the instruction stream before the execution engine processes it. And, managing all of this requires flexibility because historical legal data is notoriously messy.
I can only imagine.
We are dealing with decades of bad XML encoding, weird editorial formatting, and inconsistent drafting. Because of this, LawVM currently operates in what it calls quirks mode.
Quirks mode, meaning it has to make educated guesses when the input data is malformed.
Yes, but the key is that it explicitly records every single heuristic and recovery attempt it makes.
Ah, so there's an audit trail.
Exactly. If it encounters a badly formatted section and has to guess where the boundary is, it leaves an auditable evidence trail. The ultimate goal, which the researchers advocate for, is moving towards a strict mode, where future laws are drafted using validated digital tools so they compile cleanly without any heuristics.
That makes sense.
But for now, Quirks mode handles the messy reality of legacy data.
This theoretical framework is brilliant, treating human text as an instruction stream, handling bitemporal time travel, mapping higher-order operations. But, I mean, a compiler architecture is only as good as its output.
True.
When they finally let LawVM loose on the entire history of Finnish law and compared its mathematically compiled output to the official human-curated Finlex database, what actually happened?
This is where the project shifts from interesting computer science to generating incredible empirical receipts. They used Finland as the proving ground specifically because Finlex is non-authoritative.
Right, so we can check it against the Gazette.
Exactly. If LawVM and Finlex disagree, we can independently check the official Gazette to verify who is actually right. The initial baseline benchmark showed a 0.65% text distance and a 4.25% structural error.
Okay, that sounds like a fairly low error rate. You can look at that and say, okay, Finlex and LawVM match 95% of the time. The human editors are doing a pretty good job.
You could say that, but that single similarity score masks the true severity of the discrepancies.
Really?
Yeah. The researchers developed a residual taxonomy to categorize the disagreements. Sometimes the compiler had a parsing bug, sometimes the source XML from the government was utterly corrupted, but in a significant number of cases, the official Finlex database simply failed to apply an enacted law.
Oh, wow.
Yeah.
The sources highlight something they call the 22 golden findings. These aren't minor formatting glitches. These are cases where the official government database that every lawyer and citizen reads was fundamentally wrong, and the compiler mathematically proved it.
Exactly.
We need to walk through some of these because the implications are severe.
Let's examine the Tonnage Tax Act. If you look at the current text on Finlex, it clearly tells the public that a specific acquisition cost is fully non-deductible.
Okay.
But when LawVM replayed the historical patches, it proved that an amendment passed back in 2009 actually made that cost partially deductible for income taxable use.
Wait, really? Think about the real-world impact of that.
It's huge.
A tax regulation has been sitting on the official government website for over a decade, telling businesses they cannot deduct an expense when the actual enacted law passed by Parliament says they can.
Yeah.
You likely have companies that have paid the wrong amount of tax for years simply because a human editor missed a patch.
It's a massive failure of information delivery. And in that very same act, Finlex displayed two entire sections, Section 22 and Section 24, as active enforceable law.
Let me guess.
LawVM's compiler proved that the 2009 amendment explicitly repealed both of them.
So the government database is enforcing ghost laws, rules that were killed by Parliament but artificially kept alive by an editorial copy-paste error?
Yep. Ghost laws.
What about the Fuel Fee Act? They mentioned that one too.
That one is a structural failure. An amendment completely replaced Section 1, issuing an instruction to insert 3 brand new subsections. LawVM's parser read the instruction and compiled all 3 perfectly. Finlex only displays 2 subsections. They entirely missed the 3rd subsection concerning T1 class light vehicles. The rule just vanished into the ether.
That is wild.
Yeah.
If I own a transport company utilizing T1 class vehicles and I check the official Fuel Fee Act to ensure compliance, that rule simply doesn't exist for me.
It's alarming how fragile this is.
It really is.
We see a similar ghost law scenario in the Antarctic Environmental Protection Act. An amendment explicitly repealed Section 42 with an effective date of January 2011. LawVM correctly purged it from the active text state.
Okay, so LawVM got it right.
Right. But Finlex dutifully displays the editorial note saying the section was repealed, but then immediately below that note, it still displays the old repealed text as an active enforceable structure.
So the human editor typed out the sticky note saying, we deleted this, but forgot to actually hit the delete key on the text.
Exactly.
These examples prove that human curation at this scale is unsustainable. But the researchers didn't stop in Finland, did they? Finding errors in a non-authoritative database is great validation for the compiler, but they also tested this in Estonia. Why is that distinction so critical?
Because the Estonian system fundamentally changes the stakes. In Estonia, the consolidated text published by the government on their Regi Tataja database is legally authoritative. It is binding.
Oh,
Yeah, if the human editors make a mistake and publish a flawed consolidation, that flawed text is what legally binds the citizens.
so if the Estonian database is missing a paragraph, you can't just point to the original Gazette. The database's mistake becomes the reality.
Precisely. LawVM ran its compiler against the Estonian data and uncovered a discrepancy in the Auditors Activities Act. They found a specific phrase that was passed in the enacted amendment but had never made it into the consolidated authoritative text.
How did the Estonian authorities react when a research team showed up and used a deterministic compiler to prove their binding national law was missing words?
Well, they investigated the mathematical proof, confirmed the omission was indeed an editorial error, and officially corrected the national database.
Wow.
LawVM didn't just run a theoretical simulation. It successfully acted as an independent, auditable verification layer for a sovereign nation's binding laws.
That is a monumental achievement for the project. It validates the premise that we have been approaching legal informatics backward for decades.
We really have.
We've been trying to build complex AI to read the law without realizing we lacked a mathematically sound copy of the text for the AI to read in the first place. We've relied on human editors doing manual text manipulation when we could have been compiling it like software.
Which brings us to the core philosophical driver behind the LawVM project, what the researchers articulate as the civic principle.
The civic principle.
The fundamental premise is that the law enforced should be knowable. In a functioning democracy, citizens should not have to place blind trust in the opaque, closed-door editorial processes of a government webmaster.
I completely agree. You shouldn't be subjected to financial penalties just because an editor accidentally highlighted and deleted the wrong paragraph while updating a tax code.
Right.
The chain of custody from Parliament's vote to the citizen's screen needs to be unbreakable.
It must be auditable, reproducible, and entirely transparent. A citizen should be able to mathematically trace the enacted amendments, the exact decisions made by their elected representatives, all the way to the current text they are expected to obey. LawVM proves that we finally have the deterministic mechanics to provide that transparency.
So, whether you are a legal professional trying to advise a corporate client, a software engineer interested in complex systems design, or just a citizen who wants to know the rules of the road, the realization that our laws are effectively uncompiled code is a massive paradigm shift.
It really is.
It exposes a foundational crack in our digital infrastructure that we're only just now getting the tools to see, let alone fix. But, leaves you wondering about the secondary applications of this technology once that foundation is secure.
Yeah, where does it go from here?
Right. If human-written laws can be deterministically compiled into perfect text states to catch editorial errors within one country, what happens when we scale that up?
That's the big question.
Imagine a future where we use this compiled text state to automatically detect logical contradictions between laws across different jurisdictions.
Oh, wow.
Could we build a global compiler check that actively scans proposed bills and throws a syntax error if it detects a violation of an international trade agreement or a human rights treaty before the parliament even votes on it?
That would be revolutionary.
It fundamentally changes how we might engineer the rules of society moving forward.